Dear students, welcome to my channel. Topic of this video is image compression part 5th. In this video, I am going to explain the next lossless data compression technique, that is arithmetic encoding and lossless predictive coding, DPCM, that is differential pulse code modulation. Now let us start. Lossless data compression makes use of data compression algorithms that allows the exact original data to be reconstructed from the compressed data. It is used in many applications like popular zip file format and Unix tool gzip. It is also used as an important component within lossy data compression techniques. In my previous video, I have already explained the packbit encoding, that is nothing but RLE and Huffman. In this video, I am going to explain arithmetic coding and predictive encoding, that is nothing but DPCM. Arithmetic encoding, it generates a non-block code. Arithmetic coding can treat the whole message as one unit and single message or single number gets generated for the entire sequence. It assigns a single arithmetic code word to entire sequence of the source symbol. Arithmetic coding is more modern coding method that usually outperforms the Huffman encoding. Huffman coding assigns each symbol a code word which has an integral bit length based on their occurrences. Basic idea behind the arithmetic encoding. A message is represented by half-open interval where A and B are real numbers between 0 and 1. Initially the interval is 0, 1. When the message becomes longer, the length of the interval shortens and the number of bits needed to represent the interval increases. Each character can shorten the interval so that the more characters the interval will be. As the interval becomes shorter, more bits are needed to represent that interval. Each symbol of the message reduces the size of interval in according to with its availability occurrence. Now all these points will be easily understood with the help of example. Now we will start with the example. 4 characters are given, A1, A2, A3, A4. So file contains the 4 characters and the occurrence of their frequency, that is 1, 1, 2, 1, and probability is 0.2, 0.2, 0.4, 0.2. It is given in a problem statement. Now here this is nothing but the original table, and based on that we require to perform the arithmetic encoding for a particular sequence. Now our sequence is A1, A2, A3, A3, A4. Now we require to encode this sequence using the arithmetic encoding, and for this A1, A2, A3, A4, these are nothing but their frequencies and their probabilities. Initially we will start, that is at start it occupies the entire interval, that is between 0 to 1. Now this is A1, A2, A3, A4. Now probability is 0.2, 0.2, 0.4 and 0.2. So here it will initially takes the interval from 0 to 1. So here 0 to 0.2 because probability is 0.2. Then 0.2 is copied as it is, 0.2 to 0.4 because the probability is 0.4, 0.4 plus 0.8 and 0.8 to 1.0. So initially the interval occupies the entire space between 0.0 to 1.0. Now we will start with the table. So every time we are creating the new table and we require to take the reference from the previous table. So this is our previous table. Now we start with the encoding. Our initial sequence is A1. Now here we can see the A1 interval. A1 interval is 0.0 to 0.2. So we require to expand this interval, that is 0.0 to 0.2 like our previous. So here we expand from 0 to 1. Now we will expand same but between 0.0 to 0.2. So this is our current table. So now we modify the current table based on our previous table. Now symbols are A1, A2, A3, A4. Then here we require to take the probability of the symbol which is to be encoded. Now here the symbol or probability of A1 is 0.2. So here it is 0.2. Then difference between the previous. Now here we can see the difference between the probabilities. It is 0.2. We require to take the positive difference, 0.2, 0.4 and again 0.2. Now we require to expand the interval between 0.0 to 0.2. So 0.0 to 0.2 we require to expand. So this initially it comes 0.0. Now to calculate the next interval we require to take this initial interval which is nothing but 0.0 plus we require to take the probability of A1. The probability of A1 is 0.2 into the previous probability difference, that is nothing but 0.2. So here it is represented as A and B. So here 0.0 plus 0.2 into 0.2 is equal to 0.04. Now we will keep 0.04 here and we copy as it is. Again we require to find out the next, that's why 0.04 plus probability of that A1 is 0.2 and difference is previous is 0.2, so it is 0.08. Then 0.08 we will copy as it is, 0.08 plus 0.2 into the difference between the probability is 0.4 is 0.16. 0.16 we will write here. Then 0.16 plus 0.2 into 0.2 is equal to 0.20. So we expand, that is first symbol is A1 and A1 range is from 0.0 to 0.2. So we expand all the interval between 0.0 to 0.2 with this probability distribution. Now this table become our previous table and we will calculate for the next symbol, that is nothing but A2. Now here we require to check, this is the table. Now we require this current table becomes the previous table for the next table. Now in the previous table, now we require to check A2 because we are expanding the A2. Now A2 range will comes between 0.0 to 0.08. So we require to expand entire interval between 0.0 to 0.08. Now here we require to take the probability of A2 which is 0.2, so it is 0.2 and this is nothing but the probability difference of the previous table. So difference is 0.04, 0.04, 0.08 and 0.04. So in this way we are repeating the same step. So we will keep first value as it is and this is our last calculated value, and in between we require to expand that interval based on the probability distribution. So 0.04 we will keep as it is, 0.2 into 0.04, 0.048 we will write here, again copy here. This difference addik point plus 0.2 into 0.04, 0.056, 0.056 plus 0.2 into 0.028, 0.72 and this will come as, so entire span is between 0.04 to 0.08, and we can see that as our symbols are increases, our precision is also increases. So initially it is between 0 to 1, after that it is 0.0 to 0.2, then after that it becomes 0.0 to 0.08. Now our next symbol is A3. So this current table become our previous table. So this 0.0 to 0.8. Now we require to expand the A3 interval. So A3 interval comes between 0.56 to 0.072. So A3 symbol is there, and actually this is A3. Actually this red should be here, A3. Now we will expand between 0.056 to 0.072. So 0.056 to 0.072. Now we require to take the probability of A3 which is 0.4 and we are taking the previous difference of the probabilities. So procedure is same, only you require to take the proper current table and previous table, and in this way we are expanding the interval from 0.056 to 0.072. Next interval is again A3. So here A3 from previous table it is between 0.0624 to 0.0688. So we will expand that. Then we will again doing the same procedure, only for whatever the symbol we are expanding we require to take the probabilities of that and the difference between the probabilities from the previous table. So in this way we are expanding. Now our last symbol is remaining A4. So for A4 we are not expanding, but if expansion takes place it will take place between this. So any number between this interval we will send, and that only single number is sent to the receiver side. So for last symbol we will forward any number from A4 interval, that is 0.06752 to 0.0688 to the receiver, and for example here we forward the number 0.0679. So only single number is forwarded, but as our message length gets increases, the precision is also increases. Now at the decoder it is a reverse operation which is as below. To decode the message a similar algorithm is applied, except that final number is given and the symbols are decoded sequentially from that. So at the receiver side the symbol and their probabilities are present and the same algorithm is applied. Now the symbol sent to the receiver is 0.0679. So the same algorithm which is applied on the sender side is same applied on the receiver side. Now here it is the 0-1 interval is expanded between like this. Now our number is 0.0679. So it comes between 0 to 0.2. So the A1 symbol gets decoded. Now we will expand this interval 0 to 0.2 between all four. So we are following the same algorithm same as the sender side. Now our value is 0.0 to 0.08. Now see this value, this comes between this range. Then again A2 get extracted. Now we will expand this interval from 0.0 to 0.08. Now here we can see this value 0.06, it comes between this interval, so A3 get extracted. Now this symbol we are again expanding, again this value, whatever this sender receiver value is, again comes in this interval, so again this A3 get extracted or decoded. And finally we are expanding this interval, and we found that this value 0.0679 is lying this interval. So in this way A4 gets decoded. So in this way the encoding and decoding takes place. So after encoding, only one single number, that is floating point number, gets generated, and its precision is increases as the length of the sequence increases. And at the decoder side, same algorithm is executed, and the same type of interval is expanded based on the selection, and we will continue to decode the message. Now we'll see the another example. Now the characters are given ABC, these are nothing but the frequency, and we can calculate the probability. So probability is nothing but total number of characters, that is nothing but 5. So 1 by 5, 2 by 5 and 2 by 5. So in this way we calculate the probability. So initial interval takes between 0 to 1. So 0.0 to 0.2, 0.2 to 0.6 and 0.6 to 1.0. Now we have to encode the sequence A, B, B, C, C. Now A comes between 0.0 to 0.2. So we will expand that interval. After that we will expand the interval of B, then B, then C. And for last we will not expand the interval, but whatever that resultant table we are getting, we will take any number from the C interval. Now same as the previous procedure, so there is no need to explain. You can observe or you can solve the problem and you can easily understand. So initially A 0.0 to 0.2, 0.0 to 0.2. Now probability of A is 0.2, so we are keeping 0.2 here, and this is nothing but the difference of probability. So in this way we are expanding the interval from 0.0 to 0.2. Now we require to do for the B. So this current table becomes our previous table. Now here the probability of B is 0.4, so it comes here, difference between the probability. So we require to start from 0.04 and end with the 0.12, and in between we are expanding the interval. So we take this value as it is plus this value into this value, so we will get 0.056. It is copied again, and in this way similar calculation we require to do, that is repetitive calculation we require to do to span the entire interval. Now next again B comes, again the probability of B is 0.4. Now we will expand from 0.056 to 0.088. We will follow the same procedure. Now next symbol is C, so we require to expand this interval, that is 0.0752 to 0.088. So we will expand the same interval. Now the probability of C is 0.4. So here maybe some mistake is there, but you can take the probability of C, that is 0.4. In this way it is calculated. Now for last we will not again expand, but we will send any number between these two interval. Now we will send I have sent 0.0830, and we require to do the same operation at the receiver side. So receiver side have that characters and their probabilities, and it will apply the same algorithm. So based on that this number precision, it will expand the particular interval. So it is 0.0830. So 0.0830 comes in this interval, so A expanded. So it will expand A decoded, and again it expand this interval. So in this way the decoding takes place and the character gets extracted at the receiver side. Now similar third example, so I am not going to explain, you can try from your side. This is the input. Now initially character is A3. So A3 comes between 0.8 to 0.9. So we require to expand the entire interval between 0.8 to 0.9. So 0.8 to 0.9, it is completely expanded between this, and we require to take the probability. So initially we are now this side, 1 minute, this is not here, we require to do, as we are encoding the A3, the probability of A3 is 0.1. so here it is actually by mistake it is copied, but it is 0.1. so you can see here 0.8 plus 0.1 into 0.5, and you can see here all 0.1. So by mistake it is copied, but it is 0.1 because whatever we are encoding, we are taking the probability of that symbol. Next is A4. A4 is again 0.1, so same mistake is repeated here, but it is 0.1. So you can see this final calculation is correct. So it is 0.1 and it is expanded. For last symbol we are not expanding, but we will send any number between this A2. Now A2 comes between this and this, so any number between this we can send to the receiver. So we can send any number, so this number is get selected, and the same procedure is applied at the receiver side. So to apply the same procedure, receiver should have that characters and their probability. So in this way, it at the receiver side, it expands the interval based on this number and the symbol gets extracted. So this is nothing but the arithmetic encoding. Advantages: arithmetic coding typically has a better compression ratio than Huffman coding, as it produces a single symbol rather than several separate code words. While whole code word must be received to start decoding the symbol, and if there is a corrupt bit in the code word, the entire message would become corrupt. This is very important. There is a limit to the precision of the number which can be encoded, thus limiting the number of symbols to encode within a code word. Because as our sequence or length of the sequence of encoding increases, the precision of the number is increases, so that becomes a problem for the arithmetic encoding. Now the next technique is DPCM, that is differential pulse code modulation, and it is without quantization because we are going for lossless compression technique. DPCM tries to shrink the data by predicting each pixel's value based on the previous one, and similar technique we can use for the reducing the interpixel redundancy also. It then transmits the difference instead of the full value. There are two ways to do this: lossless and lossy. In lossless we are not using quantization, and in lossy we are using quantization, and we are doing the permanently loss of the data. Lossless differential pulse code modulation. This method employs a predictive approach, subtracting the predicted value of the sample from the actual value to generate a residual. So all these steps will get clear when we solve the example. The entire residual is then transmitted without any modification. This ensures the perfect reconstruction of the original data. However, this approach achieves the minimal compression. Now we'll see this example. Now initial data is at the center side 92, 94, 91, 97. We will write down this data. So initially our predictor is 0 because first symbol we are sending as it is. So 92, the predictor for the first time it is 0. Error is input minus predictor, that is 92 minus 0 is equal to 92. So we are transmitting the first symbol as it is. Our next symbol from the data is 94. So our predictor becomes the previous number. So this is 92 becomes our predictor. 94 minus 92 is 2. So we are sending the 2 to the receiver. Next, our predictor becomes the previous symbol, that is 94. So 91 minus 94 is minus 3. We are sending minus 3. Next, our predictor is 91. 97 minus 91 is equal to 6. So we are sending this data to the receiver side. Now as it is a lossless compression technique, exact data is reconstructed after the decoding. Now 92, initially we are keeping predictor also 0 and error is 0. Now here the formula is at the sender side, formula is input minus predictor, and here we are making the predictor, so error plus input. Now error is 0, so 92 plus 0 is 92. So we are receiving the first or reconstructing the first data as it is. After that this 92 becomes our error. So in next data is 2. 2 plus 92 is 94. So now this becomes 94 here. Minus 3 plus 94, 91. Then 91 comes here. 6 plus 91 is 97. So in this way we are getting the correct data as we send from the sender side. So this is nothing but the predictive, and such similar type of techniques are used to reduce the interpixel redundancy also. Now you can observe the same similar example for this DPCM. So as it is a lossless, so we are getting the same data. So this is same as previous, so I am not explaining, but the idea is same. So this is all about the lossless compression technique, about arithmetic encoding and DPCM. So in fourth and fifth video I have explained 4 types of lossless data compression technique, that is packbit encoding, Huffman encoding, arithmetic encoding and DPCM without quantization. Thank you.